The final question that you might have about testing is how do you create a test for something that interacts with the database? So here's the register submit function, which I showed you at the beginning of this topic, where we've got the validate registration function. I've showed you how to test that, but how do we test this function in its entirety? Because there's a few different things going on here. If this is successful, then we need to check that the data has actually been sent into the database correctly. In principle, we could do it like this, and this is not the way that you should do it, but I'll walk through what's going on here and explain the principle. So in principle, if I was testing the submit button, I'm testing that a record is added into the author table when the registration form is submitted. So firstly, what I want to do is make sure there's no test record in the database already. So I would delete from the authors table the test record I'm about to insert, because then every time I rerun the test, I'm starting from the same blank slate. And then for a double check, I'm just ensuring there actually is no record in the database with that, because that could give us a false positive. So I'm doing select star from author where email equals john@example.org, and then fetching the record and then adding an assertion that says, check there is actually no record in the database at the moment. Because if there was any result from the test where we're adding a record with that email address, could be flawed. So what I'm doing here is I'm making sure there's no record in the database with that email address, so that then at the end of the test, I can check to see after the submit button's been pressed, is there a record in the database with that email address? So I'm starting off by checking there is no record in the database with that email address, calling the function that adds the record, and then finally checking that that record has been added correctly. So there's several stages to this test. Then I take my controller and create an instance of it, run the register submit button, which, as you'll remember, is now using the post data that's coming in as an argument rather than itself using $_post. And then after the submit button's been pressed, if this has run successfully, what should happen at this point is there should now be a record in the database with this information. So there should be a record with the first name of John, the surname of Smith, email is john@example.org, and the password is secret. Okay, in reality, that would probably be hashed and it wouldn't actually be stored like that. But for now, we'll just assume that it's very insecure. So what I could do is just check that this value is not false. So I could just check it's not false. In the same way that I've checked that it's false here, I could just check that a record now actually exists. But that only partially solves the problem, because just because a record exists doesn't mean that the function is working as intended. So for example, my function could be working in such a way that it writes the first name and the surname into the wrong columns. So even though this is the test data, the function could have a bug where it puts Smith in the first name column and John in the surname column. And I need to test for that. I need to test that the actual correct data has gone into the database. So I'm fetching the record from the database and then adding an assertion for each piece of information. So I'm checking, does the first name from the database equal the first name from the test data? Because I'm saying at this point, after this function has been run with this test data, the first name in the database should be John. The surname in the database should be Smith. The email in the database should be john@example.org, and so on. And there's a few potential things that could happen here in a real test. The column could be the wrong type. So for example, the surname column could be set as an integer. And when the test runs, it would actually insert 0 into the surname column. So there's a few potential issues that could exist in the system that mean that I can't just check that a record now exists, because I want to check that the data can actually be written to the relevant columns. You could also have it set up as varchar2, so it would only accept 2 characters, and the surname would then be SM rather than Smith. Or any of the columns could have the wrong data type or a truncation of the data. So we need to test for that and check that the full data that we tried to insert was inserted correctly into the database. And that's why I've got this series of checks here. Now, it already said this isn't actually how you would go about solving that kind of problem. Because as you can tell, this is a really long-winded way of solving the problem. And this also requires a real database connection. And that we don't really want in a test. We don't really want a real database connection. We want a fake database connection. We want to test the code is correct without worrying about what the database is doing. We can test that separately later on. And if one of these assertions failed, and say the first name from the test data isn't the same as the first name from the database. So if those two aren't the same, we don't actually know that much about what's gone wrong. Because when the register submit function runs, it calls the save function in the database table class. So we don't know if the test is failing because of an issue in this code, or an issue in this save function, or an issue in one of the functions that the save function calls. So we don't actually know where the issue is. We don't know if the issue is in this function called save or in this function called register submit. And that makes for a poor test, because ideally, if a test fails, we want to know exactly the point in the code at which the test fails. I don't want to have to go and dig through every function that this function calls, and then every function that the save function calls, and then every function that those functions call, and have to go through the entire chain testing each part of the function. I want to know if there's a bug in this function or a bug in this function. So in reality, I'll have a different test that tests the save function. I'll have a whole series of tests to ensure the save function works correctly. And that will be done in a different test class. And then I'll have a test that checks if this function is working correctly. And to do that, we want to isolate the code that is being tested. We don't actually want to execute any of the other code. We don't really want to go off and execute the save function and then actually insert into the database and run all that other code as part of the test. As part of the test, we only want to run the exact function we're running and nothing else. But that presents a problem, because this function relies on the save function from the authors table instance. It needs to run that. We can't just comment out that line of code for the purpose of testing it, or skip that line of code entirely. But during our test, we'll assume that this function works as intended. We'll assume there's some other tests checking that this function works as intended, and that we are just going to test this function here. So we're not actually going to call the save function. We're going to assume that works, and there's another test for that particular function to make sure that save function works as intended. The test we're doing for this function will only run the code in this function. It won't go off and run save, and that won't go off and run something else and something else and something else. But if we've got that call to the save function in our registration function, how do we not have it call the save function and then go off to the database? Because that instruction is in the code. So we need to find some way of overriding that save instruction so it doesn't actually go off and do any real task. To do that, we can use something called a test double, or a mock object. And although you can generate these in PHP Unit, and I'll show you how to do that, I want to show you how you would do it manually first, so you've got an idea of how this works. So what you would effectively do is create a version of the database table class like this. So we're creating a class called mock database table with a function called save in it that has whatever arguments are needed by the real function, but has no code in it. So it's just a class that you can use in place of the database table class that looks kind of the same, but actually doesn't do any real processing. And that allows us to use the mock version of the class in the test and have a test that doesn't rely on a real database table instance or a real database connection. And if the test fails, we know that it fails solely because of the code in the function being tested and not the code in one of the functions that gets called. Because we're providing a mock version of this class that doesn't actually do any processing itself. Our test is going to assume that there's another test for the real version of this function and then just use a dummy version of this function in our test and assume that the save function is working correctly. And our test now looks like this. Rather than passing a real authors table instance here, which is linked to a real database, we create the mock object, which has got the save function inside it, that actually does nothing. So when this test runs, we're ignoring the fact that the save function is required. And when we create an instance of the author class, which is the class that contains this function, instead we provide it an instance of the mock class. That's this one here that's not doing anything. So we're actually providing an instance of this class as the constructor argument to the author class, and then when it runs this authors table save, it's actually running the save function from this class, which does no real processing. And what that means for our test is that if there's an error in the test and the test fails, the test can only have failed because of an issue in this function. So if we get a test failure, we know that the issue has to be in this function and not in the save function, because the save function is no longer doing anything. And now to test that this is working correctly, we would just check the return value of the register submit function. And we know if it's successful that the function should return the register success.html.php template rather than the registration form. If there's a problem and it runs this block, it will return the registration form. So what we're saying when we run this test is, with this test data, the data should be sent to the database as intended, but we're assuming that the save function works, and we're just checking that this passes the validation and returns the correct template. So we're saying that the template of the result should be the success page. We would then have a separate test to check that the save function works correctly. And for anything that directly interacts with the database, like the database table, we can use a real database, but we only want that one level deep. So any class which directly interacts with the database, it actually sends it insert queries, update queries, and so on, that can have a real database connection. But anything a level above that calls the database, we'll just use a mock version of the database table class. So the logic I had before for delete the record, check the record doesn't exist, set up some test data, and then insert it into the database can still be used, but it will be used on the save function. And we'd use the save function with various different inputs to ensure that the save function is working as intended. But that's not checking at the same time the register submit. We'd have one test that checks the register submit function works, and one different test that checks to see if the database table class's save function works. And they would be completely different tests, and they would only test that particular function in that particular class. The problem with this is that we're assuming that the save function works as intended. And even if we've got perfect tests for the save function and we've tested the save function works as it should do, and we know that it does in a completely different test, what we're not checking here is that the save function is being given the correct information. So actually it's been given this array here, post author. But part of this function's job is to send the correct information into the save function. I might have forgotten to put the argument in here. And if we're using a mock version of the database table, that's not going to cause an issue at all. So we do need some way of checking to see whether this mock version of the save function has actually been given the correct test data. And for each test we write, we could create a different version of this mock database table class. So we'd have one version per test. So for the one with this test data, we could add some logic to the save function that says, for this test, I'm expecting the save function to be called with the first name set to John, the surname set to Smith, the email set to johnexample.org, and actually that should say password set to secret. And then in our test, when we create an instance of the mock database table class, we're not creating an instance of a class that contains no functionality in the save function. We've got a version of this class that exists specifically for this test with this test data. And we're saying that when the register submit function is called, and when that then goes off and calls the save function, we're expecting the data sent to the save function to be this data. And if that's the case, I've just set the class variable valid to true. So when this runs, if all of this information has been correctly sent to the save function, as would be the case if the register submit function is correct, then it sets this valid to true, which is a class variable. And the test can now check to see if authors table's valid variable, which is this one here, is set to true or not. And the reason we're doing that is because we want to ensure that when this function runs, it calls the save function with this data. If it doesn't, the valid variable is never set to true, and we know there's an issue with the test. And if for some reason the register submit function does not ever call the save function, or calls it with the wrong data, that's data that doesn't look like this, then the test will fail, and we'll know we've introduced a bug into the function. By using a mock function that says we expect the save function to be run with certain data, we're then able to check that the register submit function, which is the one we're testing, is correctly calling the save function with the right data. And in the real application, where the save function is the real version of the save function, not the dummy version, which we've got here, and not the mock version, which we've got here, we know that it will be sent the correct information and the data will be handled correctly. And we've now got a very robust test. We're checking that the register submit function is returning the correct value and also calling the save function in the database table class with the correct data. But we're not actually testing the actual save function. There's no way for this save function to work incorrectly. There's absolutely no way that this will cause a bug. Okay, you could write the test wrong, but that goes for any line of the test at all. But assuming we set up the mock version of the class correctly, if there's a bug, if the test fails, the issue must be in the register submit function. It can't possibly be in this function here. So that isolates the code that we're wishing to test.